Let's take a look at this example. This time we are going to deal with a little bit different circuit. So first, what we're supposed to do, we're supposed to count the number of nodes. We have one node. Okay, this is going to be my reference node because it's connected to the ground, and I have these two nodes. Okay, so this is my ground. So this node I'm going to call V1, and this one I'm going to call V2. Okay, so I have voltage source over here. Okay, so the current is going to be pushed in this direction from this voltage source, and I'm going to call this current I1. This is going to be my current I, okay, because this is my I, and this is going to be my I2, okay, and this is going to be my current I3. Next, I'm going to write the KVL for my currents. So I have I1, and I1 is positive because it's going to the node V1, minus I2 because I2 is leaving this node, and minus I because I is also leaving the node, and this is equal 0. This is the KVL for this node. Now someone is going to ask, but we do not have I1 and we do not have I2, so we have to find it. Simply, please realize that I1 is equal to voltage source minus V1 over R1. Okay, so this voltage minus voltage at this node divided by the resistance R1 will give me current I1. Okay, I always follow the current. Okay, so if the current goes, let's say, in this direction, so I'm going to subtract from Vs V1. Next, I'm going to find the formula for I2. I2 is equal simply voltage across resistor R2, which is the difference between these two voltages. So I have V1 minus V2 over R2. Okay, so this is my current I2. Next, I'm supposed to simply rewrite this formula. Okay, I'm going to write that I have I1 minus I2 is equal I. Okay, I moved this I to the right side, that's why it became positive. Next, I have to substitute I1 by Vs minus V1 over R1. So I have Vs minus V1 over R1, and I have minus I2, which is equal V1 minus V2 over R2 is equal I. Next, I'm going to simply rewrite this single fraction as two fractions, and the same I'm going to do over here. So I have Vs over R1 minus V1 over R1, and I have minus V1 over R2 plus V2 over R2. I simply distribute this negative sign into the numerator, so my V1 became negative and V2 became positive. So this is equal I. Now I'm supposed to make the factorization. So I have V1. Okay, so I'm going to factorize V1 from these two terms. I have negative V1, and inside of the parentheses I'm going to have 1 over R1 plus 1 over R2, close parenthesis, plus V2 over R2, and I have equal I, and I'm going to move Vs over R1 to the right side. That's why this is going to be negative Vs over R1. Next, I'm supposed to substitute the variables by the values of my voltages and resistors. So I have negative V1, and I have 1 over R1 is equal 4 kilo ohms. I have 4 kilo ohms plus 1 over R2, which is equal 6 kilo ohms, close parenthesis, plus V2. Okay, I'm going to write V2, and I have 1 over R2, which is equal 6 kilo ohms, is equal I 3 milliamps minus Vs, which is equal 60 volts over R1. R1 is equal 4 kilo ohms. Okay, so I have negative V1, and now I'm going to use the calculator. So I have 1 divided by 4 exponent 3 plus 1 divided by 6 exponent 3 is equal, I would say this is 417 microsiemens. Okay, plus V2, and I have 1 divided by 6 exponent 3 is equal, I would say 167 microsiemens is equal 3 exponent 3 negative minus 60 divided by 4 exponent 3. This is equal negative 12 milliamps. Okay, so this is my first equation. Next, I'm supposed to find the second equation because I have two nodes. Okay, because I have two nodes. Okay, this is my reference one, that's why I don't count it. So I have two nodes, and it means that I'm going to need two equations. So this is my first equation, and now I'm supposed to write the second equation. So let's take a look what we have over here. Start with the currents first. So I'm going to have I going to the node 2, and I2 also is going to go to the node 2, and I3 is going to leave node 2. That's why I'm going to write that I is positive because it's coming to the node, plus I2 minus I3 is equal 0. Let me make myself clear one more time. I is going to the node 2, and I2 is going to the node 2 also. Okay, I3 is leaving, that's why these two currents are going to be positive, I3 is going to be negative, and everything is equal 0. That's why I have this equation. Now I'm supposed to move I to the right side because I is given, it's equal 3 milliamps. So I have I2 minus I3 is equal negative I, where I2 we found this is equal V1 minus V2 over R2. So I have V1 minus V2 over R2 minus I3, which is V2 over R3. Okay, let me remind you that voltage V2 is voltage across resistor R3. So voltage across the resistor R3 divided by the resistance R3 is going to give me I3. That's why V2 over R3 gives me I3. So I have V2 over R3, and this is equal negative I. And I is equal 3 milliamps. I have 3 milliamps. Okay, so I'm going to substitute right now this fraction by two fractions. So I have V1 over R2 minus V2 over R2 minus V2 over R3 is equal, as I said, negative 3 milliamps. Next, we're supposed to simply do factoring, so just make V1 over R2 minus V2 1 over R2 plus 1 over R3. This is equal negative 3 milliamps. Okay, so now we're supposed to plug in the numbers. So I'm going to plug in the numbers over here. So I have V1 and I have 1 over R2, and R2 is 6 coulombs. Okay, minus V2 and I have 1 over R2, so I have 1 over R2 is equal 6K plus 1 over R3, which is equal 12K. Okay, and everything is equal negative 3 milliamps. Okay, so next I'm supposed to use the calculator, and I have 1 divided by 6 exponent 3 is equal, so I have V1 is 167 microsiemens minus V2, and I have 1 divided by 6 exponent 3 plus 1 divided by 12 exponent 3. This is equal 250 microsiemens, and everything is equal negative 3 milliamps. Okay, so this is my second equation. Next, I'm supposed to simply write these two equations together and solve these two equations for V1 and V2. I copy down the two equations which we obtained, and now we're supposed to solve these two linear equations for V1 and V2. I'm going to use the calculator to do that. So I have negative 417 exponent 6 negative, and I have 167 exponent 6 negative, and I have negative 12 exponent 3 negative, and I have 167 exponent 6 negative, and I have negative 250 exponent 6 negative, and I have negative 3 exponent 3 negative. So the value of V1 is equal 45.84 volts, and I have V2 is equal 42.62 volts. Okay, so I found the voltages at the nodes V1 and V2. So this is the voltage between this point and ground, and this point and ground. So now we're supposed to find value of the current which goes through resistor R1, and we have to find value of current which goes through the resistor R2, and find the value of current which goes through resistor R3, and find power at resistor R2. So I'm going to find the current I1. we have formula already given. I1 is equal voltage source minus V1 over R1. I'm going to use this formula to find I1. So I have, let me write this down over here. I1 is equal voltage source minus V1 over R1, where voltage source is given, this is 60 volts, minus V1, which is equal 45.84 volts, over R1, which is equal 4 kilohms. Okay, so I1 is equal, I have 60 minus 45.84, okay, equals, divide by 4 exponent 3. This is equal 3.54 milliamps. So this is 3.54 milliamps. So this is my current I1. I2, again we have formula given. I2 we said is equal to V1 minus V2 over R2. So I have V1 minus V2 over R2. V1 is equal 45.84 volts, okay, minus 42.62 volts over R2, which is equal 6 kilohms. This is equal, so I have 45.84 minus 42.62 is equal, divided by 6 exponent 3. This is equal 536.67, I can say 67 microamps. Okay, so this is the current I2. Next we're supposed to find current I3. I3 is equal V2 over R3. Okay, let me repeat myself one more time. If you are going to divide the voltage V2, which is voltage across this resistor, by resistance R3, you are going to obtain the current I3. Okay, so let's perform the calculations. So I have V2 equals 42.62 volts divided by R3, and R3 is equal 12 kilohms. We are going to obtain 42.62 divided by 12 exponent 3. This is equal 3.55 milliamps. So this is 3.55 milliamps. Next, the problem is asking me for the power at resistor R2. The formula for power says, let me write this over here, P2 is equal I2 squared times resistance R2. Okay, so this is equal, I2 we found is equal 536.67 microamps to the second power times, let me write this over here, times R2, which is equal 6 kilohms. This is equal, here's the calculator, so I have 536.67 exponent 6 negative square times 6 exponent 3. This is equal 1.72 milliwatts. Okay, so this is my power P2, and at this moment I can say that the problem is solved.